Hello everyone, welcome back to Pachehra Talks. My name is Arun and I'm working with Tech, which is one of the best organization to work with. And today we are going to continue uh, neural networks. In the previous video, we understood what is neural networks and how exactly it works, yeah, neural networks, basic structure and things like that. We could also understand here, right? All those methods with the examples that we did: forward propagation, activation, functions, learning process, and training. I'm just going through this just to review so that you guys cope up if you're not going through rigorously with these videos. All right, so today we are going to talk about types of neural networks. We know what is neural networks. Now we need to understand the types of neural networks, and we are going to understand through this MS Paint so that it will be easy to write and understand the structure, how exactly it helps. So there are four types of neural networks in Gen AI that we are going to explore today. The very first is generative adversarial networks, or GAN. GAN, this neural network consists of two neural networks, a generator and a discriminator. Okay. Now, generator, as the name says, it generates. Okay. And discriminator, as the name says, it discriminates. What it generate and what it discriminate, that we'll understand. And what exactly it is a competitive process to train, to create highly realistic data. Why? Because generator is going to create new data which is indistinguishable from the real data. All right. And what discriminator will do? This network will see the new data and find the problem or disconnect or distinguish between real data and generated data. All right. It will try to generate new data which is indistinguishable from real data. But discriminator will find the commonness, similarness, sameness, so that it will ask generator to improve and create more data, more realistic. So that's the competitive process. It will keep pushing this model to create more relevant, more undistinguishable or indistinguishable data, and it will create highly realistic data or high quality uh, generator or high quality real data, kind of real data. All right, we can easily understand this with this example. Imagine you're working on a project to create a digital art exhibition. You want to include networks that resemble the styles of famous painters, let's say Picasso, but also want something original. Using this model, GAN, you can train generator to produce new images, right? By learning how, by learning from a data set of Picasso's paintings. All right, that's what the generator is doing. Now, the discriminator helps refine these generated images by comparing them to the original artworks, pushing the generator to create high quality images that closely mimic the style of these painters yet are entirely new creation. So what it is a competitive process, and it will help us to create high quality, highly resilient or resemblance with the original paintings. This is our first GAN, or generative adversarial network. We understood this network works on competitive process. It has two neural networks, generator and discriminator. Both do the competition to produce the high quality data. All right, let's put it there in the corner. And the next one is variational autoencoders, or VAE. Now, VAE is designed to compress data into a lower dimensional representation and then reconstruct it reconstruct it into original form. During training, VAE learn the parameter of probability distribution representing the data. Okay, what it learns during training, this model learned the parameters of the probability distribution representing the data. Probability distribution representing the data. Once trained, they can generate new data by sampling from the distribution. All right. And you can, if you stay with me with the example, you could easily relate what exactly it means. So VAE are used in various applications like image generations or anomaly detection, those kind of things. And let's take an example of emojis. Okay. So consider you are developing an app that can customize emojis based on user photos. You want the app to capture the essential features of user's face, like the shape of the eyes, mouth, and nose, and then generate emojis that retain these characteristics. Now, this model can compress the photo into a compact representation, capturing the key facial features, right? Probability distribution representing the data here. Now, it's sampling this distribution and then reconstruct it into a emoji format. By manipulating the compact representation, the app can generate a variety of emojis that resemble the user's facial features, offering a personalized emoji experience. You might have seen that around, right? So that's how this one works. VAE or variational autoencoders model of neural network. Let's put it there. And the third one, it is auto regressive model. All right. And these model predict the next item in a sequence based on the previous items. Sounds very familiar. Yeah, if you're following the series, of course, you'll find it very familiar. In the context of Gen AI, autoregressive models like ChatGPT or generative pre-trained transformers are used to generate coherent and contextually relevant text. They are trained on a large corpus of text data and can generate new text sequence that are similar in style and content to the training data. So that's how it works. Now, if you it's not clear to you, let's take an example of authors writers block example. Let's suppose you're creating a tool to help authors overcome writer's block, which is a common thing. If you read books, if you read about authors, you know. So how it overcome? By generating story ideas or continuing where they left off. By training an autoregressive model like GPT on a diverse collection of literature, the tool can generate text that follows the style and context provided by the author. For instance, if the author writes the beginning of the fantasy story, the model can suggest how the story might continue, generating ideas for the characters, plots, or dialogues that are coherent with the story's beginning, right? Interesting, right? So this autoregressive model helps this way and learns that way. We talked about both. And the last one is in our small series of understanding types of neural networks, the most relevant one, the transformer models. So what it is, beyond text generation, transformer architecture have been adapted for generating tasks in other domains as well, such as image generation, like DAL-E, and music generation. These models are highly effective in capturing long-range dependencies and complex patterns in data. That's their beauty. Now, let's put this in an example so that it will make more sense to us. Suppose you are part of a team developing a video game that includes dynamic dialogue with non-player characters, NPCs. If you are interested in video games, you know that. So what do? You want these dialogues to adapt based on these players' actions and the game's storyline. A transformer model can be used to generate dialogue on the fly, ensuring that conversation with the NPCs feel natural and contextually appropriate. Beyond text, transformer models adopted or adapted for generative tasks could also be used to create diverse game environments or background music that changes based on the game's events. So that would be an interesting example. All right, so we have understood all these types of neural networks and how exactly it helps. Now, the question is how they get trained. How they get trained. So, if we talk about training, and we are talking about all these models one by one. So, let me put it here and let's train the GAN first. That's the first we learn generator and discriminator. So it involves a game like scenario where the generator improves the ability to create data that looks real, while the discriminator becomes better at telling real from fake. This adversarial training continues until the generator produces highly realistic data. Right? That's how it gets trained, the competitive process that we talked about. Now, what was the second model? VAE model, right? What was it? The data example, if you remember. So it focuses on learning a compact representation of the data, latent space, and how to reconstruct data from this space. This model is trained to minimize the difference between the original data and its reconstruction, emojis, if you remember, right? Along with the regularization term that ensures the latent space has good properties for generating new data. All right. Then, if we talk about the third one, which was auto-regressive or transform model, both almost trained in the same way, auto and transformer. So these models are trained on large data sets to predict the next item in sequence, like GPT, learning complex patterns and structures within the data. Once trained, they can generate new sequences by iteratively predicting the next item based on the items generated so far. So that's how the basically the training happens. We can take an example to make more sense for this. Imagine training these models is like learning to cook by following recipes. Initially, you learn by predicting the next ingredient or step item in a sequence based on the previous ones as you practice with a variety of recipe, which could be your data set. You start understanding complex patterns like how certain ingredients combine or the order of steps to achieve the best results. Eventually you can start creating your own recipes. That's what the humans do, right? So by deciding what ingredient or item comes next based on what you are already added or you have already added, crafting dishes that follow the this logic. So that's how it can it trained itself. So generative AI models are specialized neural network architectures tailored to their specific task of generating new content, whether it's creating images that look like photographs, generating human like text, or composing music. These models learn from vast amount of data to mimic the underlying distribution. The choice of model and training process depends on the type of data and the specific requirement of the task at hand. What exactly are we preparing this model for? All right. Now we can take a few examples. These neural networks are like versatile and can be applied to a wide range of tasks in AI. That's the reason we are taking some examples like image and speech recognition, NLPs like natural language processing or predictive analysis. There are few examples, but the main agenda for this video was to understand the types of neural networks and how they get trained. And I think we pretty much covered what we planned. Well, thank you for watching, and I hope it was helpful and informative. You guys have a wonderful day. Just take care. Bye bye.